My dear students, welcome back to our channel. In this video, I will be explaining the Bcom second semester subject Programming with C and C++ as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 5 first important short question is: define OOP. OOP stands for Object-Oriented Programming. It is a way of writing programs by using objects and classes. It helps to organize code better and makes it easier to reuse, understand, and update. In OOP, we create objects that represent real-world things, like a car, student, or mobile. Each object has properties, like name, speed, and actions like drive, call. The main features of OOP are: class, a blueprint, design of an object. Object, a real example of a class. Encapsulation, hiding data inside a class. Inheritance, one class can get features of another. Polymorphism, one function can work in different ways. Example: class car. Public. Void drive. Count car is driving. int main. Car my car. My car dot drive. Return 0. This makes programming in C++ more powerful and closer to real-life thinking. Next important short question is: 2 advantages of OOP. Object-oriented programming, OOP, has many benefits that make coding easier and smarter, especially in C++. It helps us build real-world based programs. Main advantages: 1. Reusability. Once a class is created, it can be reused in many programs. Example: a student class can be used in college, school, or tuition apps. 2. Easy to manage. Code is divided into objects, so it becomes neat and organized. 3. Data security, encapsulation. Important data is hidden inside classes, protecting it from outside misuse. 4. Inheritance. New classes can be built using old ones, saving time and effort. Example: a bike class can inherit common features from a vehicle class. 5. Polymorphism. Same function name can perform different tasks based on the object. Conclusion: OOP makes C++ programming more powerful, real-life based, and easy to update or expand in the future. That's why it's widely used in modern software development. Next important short question is: 3. Define the terms class and object. Give examples. In C++, a class is a blueprint or template used to create objects. It defines the data members, variables, and member functions, actions, that the object will have. An object is a real-world example of a class. It uses the properties and behaviors defined in the class. Think of a class like a mobile design, and an object as an actual mobile phone made using that design. Example: class student. Public. int roll no. String name. Void show. Count roll no, name NDL. int main. Student S1, S1 is an object. S1.rollNo is equal to 101. S1.name is equal to Ravi. S1.show. Return 0. Conclusion: class is equal to design. Object is equal to real thing based on the design. Objects bring the class to life and help us write real-world based programs. Next important short question is: 4. Data members. In C++, data members are the variables that are declared inside a class. They store the information or properties of an object. Think of a class as a design, and data members as the details it holds. Example: class student, public, int role no, data member, string name, data member. Here, role no and name are data members of the class student. When we create an object from this class, each object will have its own roll number and name. Usage: student S1. S1.rollno is equal to 101. S1.name is equal to Rahul. Types: private can be accessed only inside the class. Public can be accessed from outside the class. Protected, used in inheritance. Conclusion: data members help describe the properties of objects. They are a basic part of OOP and are very useful in building real-life applications like school, bank, or employee systems. Next important short question is: 5 member functions. In C++, member functions are the functions or methods that are written inside a class. They define the behavior or actions of an object. If data members tell what an object has, then member functions tell what an object can do. Example: class student, public, int role no, string name, void display, member function, count role no ndl, count name ndl. Here, display is a member function that prints the student's details. Usage: student S1. S1.rollno is equal to 101. S1.name is equal to Amit. S1.display, calling member function. Types: inside the class, outside the class, with scope resolution. Conclusion: member functions help an object perform tasks. They work closely with data members to make the class useful. They are essential for writing meaningful programs in C++. Next important short question is: 6. Encapsulation. Encapsulation in C++ means binding data and functions together into a single unit, class, and hiding the internal details from outside access. It is like a medicine capsule. The ingredients, data, are safely packed inside. With encapsulation, we make data members private so they can't be accessed directly from outside the class. We use public functions, getters, setters, to access or update them safely. Example: class student, private, int role no, hidden data, public, void set role no, intr, role no is equal to r, int get role no, return role no. Usage: student S1. S1.set role no, 101. Count S1.get role no, outputs, 101. Conclusion: encapsulation gives security, control, and clean code. It protects data from accidental changes and is an important pillar of object-oriented programming. Next important short question is: 7. Abstraction. Abstraction means showing only the important details and hiding the complex parts from the user. In C++, we use classes to achieve abstraction. Example: when you use a mobile phone, you just click buttons to call or message. You don't need to know how it works inside. That's abstraction. In programming, we hide the internal code and show only what is needed. This makes the program simple and easy to use. Example: class calculator, public, int add, int a, int b, return a plus b. Here, the user only uses the add function. They don't need to know how the addition is done inside. Benefits of abstraction: reduces complexity, increases security, makes code cleaner and easier to maintain. Conclusion: abstraction in C++ helps you focus on what something does, not how it does it. It is one of the key features of object-oriented programming. Next unit 5. Long questions. First important long question is: discuss the structure of a C++ program. A C++ program follows a specific structure or format. This structure helps the compiler understand what to do and how to run the program. Learning the structure is the first step to writing any C++ program correctly. Basic structure of a C++ program. Hash include iostream1. Header file. Using namespace std. 2. Namespace. 3. Main function. int main. 4. Body of the program. Count hello world. Return 0, 5. Return statement. Explanation of each part. 1. Header file. Hash include iostream. It tells the compiler to include the input-output stream library. It is needed for using count, cin, etc. 2. Namespace. Using namespace std. It lets you use standard C++ features without writing std, count, std, cin again and again. 3. Main function. int main. Every C++ program must have a main function. It is the starting point of the program. The execution starts from here. 4. Program body, inside, of main. This part contains the actual code. You can declare variables, take input, show output, and write logic here. 5. Return statement, return 0 winking smiley. This tells the compiler that the program ended successfully. 0 means no error. Important points to remember. Semicolon is used to end every statement. Curly braces are used to define blocks of code. Comments, like this is a comment, are used to explain code but are ignored by the compiler. Example output. Hello, world. Conclusion. Understanding the basic structure of a C++ program is like knowing the frame of a house before building it. Once you know this format, writing and understanding any C++ code becomes easier and more fun. Next important long question is: to explain the storage classes of C++. In C++, a storage class defines how a variable behaves, like where it is stored in memory, how long it exists, lifetime, who can access it, scope, what its default value is. There are 4 main storage classes in C++. 1. Auto, automatic storage. This is the default storage class for local variables. Memory is created when the function starts and destroyed when it ends. Void show. Auto int x is equal to 10. Count x. Scope local. Lifetime within the block. Default value, garbage value, undefined. 2. Register. Stores variable in CPU register for fast access. We can't use address of and operator with it. Register int speed is equal to 100. Scope local. Lifetime block. Default value garbage. Note: compiler may ignore the request. 3. Static. Keeps the variable alive even after the function ends. Retains the last value when the function is called again. Void counter. Static int count is equal to 0. Count plus plus. Count ndl. Scope local to function. Lifetime entire program. Default value 0. 4. Extern. Used to declare a global variable in another file or before it is defined. It connects different files together. Extern int a declared here. Int a is equal to 5 defined later. Scope global. Lifetime entire program. Default value 0. Conclusion. Storage classes control the life, location, and visibility of variables. Knowing them helps in efficient coding and memory management. Think of them as different types of lockers for your variables. Next important long question is 3. Write the differences between C and C++. C and C++ are both popular programming languages, but they have some important differences. C is a procedural language, while C++ is an object-oriented language. Let's understand this in an easy way. Main differences between C and C++. Feature C language, C++ language. Programming type procedural, step-by-step, object-oriented programming, OOP. Focus focuses on functions and procedures focuses on objects and classes. Classes objects not supported fully. Data security less secure, no encapsulation, more secure, uses encapsulation. Function overloading not allowed. Code reusability difficult easy due to inheritance. Standard I/O uses printf and scanf, uses count and cin. File extension .c.cp. Example in C. Hash include stdio.h. int main. Printf hello from C. Return 0. Example in C++. Hash include iostream. Using namespace std. int main. Count hello from C++. Return 0. Key points to remember. C is like a small toolbox, simple but limited. C++ is like a big smart toolbox, full of advanced tools like classes, inheritance, and polymorphism. C is best for system-level programming like operating systems. C++ is used for software development, games, and GUI apps. Conclusion. C++ is an improved version of C, with more power and flexibility due to OOP. If you understand C, learning C++ becomes easier. Just remember, C teaches you how to build, and C++ teaches you how to build smarter. Next important long question is 4. Explain in detail the various types of inheritance. In C++, inheritance means one class, child, can use the properties and methods of another class, parent. It helps to reuse code and build relationships between classes. Think of it like a son inheriting land from his father. The son gets the property without building it from scratch. Types of inheritance in C++. 1. Single inheritance. One child class inherits from one parent class. Class parent. Public. Void show. Count parent class. Class child, public parent. Inherits show. Simple and easy. 2. Multilevel inheritance. A class inherits from a class that is already inherited from another class. Class grandparent. Public. Void greet, count hello from grandparent. Class parent, public grandparent. Class child, public parent. Passes data from one level to another. 3. Multiple inheritance. One class inherits from more than one class. Class father. Public. Void work, count working. Class mother. Public. Void care, count caring. Class child, public father, public mother. Child gets features from both parents. 4. Hierarchical inheritance. One parent, many children classes. Class animal. Public. Void eat, count eating. Class dog, public animal. Class cat, public animal. Multiple classes share common features. 5. Hybrid inheritance. A combination of two or more types of inheritance. It can become complex and needs careful design. Conclusion. Inheritance helps in code reusability, better structure, and easy maintenance. By using inheritance, you can build big programs faster, like making different types of vehicles, students, employees, etc., all from a common base. Next important long question is 5. Explain in detail about polymorphism. In C++, polymorphism means one name, many forms. It allows the same function name or operator to behave differently based on context. Think of a TV remote. The same button works for different devices, TV, AC, set-top box, depending on the mode. That's polymorphism. Types of polymorphism in C++. 1. Compile-time polymorphism, also called static polymorphism. It is decided at compile time. Achieved using function overloading, operator overloading. Function overloading, same function name with different parameters. Class print. Public. Void show, int a. Count number a. Void show, string name. Count name, name. Output depends on argument type. Operator overloading, same operator works differently for objects. Class add. Public. int x. Add int a, x is equal to a. Add operator plus, add obj. Return add x plus obj.x. We can use plus with user-defined objects. 2. Runtime polymorphism, also called dynamic polymorphism. It is decided during program execution. Achieved using inheritance. Virtual functions. Example. Class animal. Public. Virtual void sound. Count animal sound. Class dog, public animal. Public. Void sound. Count bark. Animal asterisk a. Dog d. A is equal to and d. A sound outputs bark. Function is chosen at runtime based on object type. Conclusion. Polymorphism is a powerful feature in C++ that allows flexibility and code reusability. It helps in writing cleaner, shorter, and smarter code, especially in real-world applications like calculators, games, billing systems, etc.